Hello, welcome back to the Rising Stars Working Scientifically webinar. This is the second one. If you're just joining us for the first time, you missed out on a great session last week. Those of you that were here last week, you'll know to look out for the code word, which is just written behind us here. So we have 3 code words, one that we are issuing on each of the sessions. If you collect all 3 code words, we'll be able to issue with certificates at the end of the courses so that you can pop that into your portfolio and recognition of the work that you've been doing as part of this course. I'd like to thank Rising Stars for again pushing this forward and sending around the materials, and you'll have noticed that this week we're using live stream as opposed to Google. Huge apologies to those of you that have asked your teams at school to address some of the issues that you had around Google last week, but we found that the quality of the recording wasn't suitable for post-course use, which is why we switched to live stream, and we intend to use live stream next week, so hopefully any glitches that you've had experienced so far will be ironed out. We've also tweaked the hashtag that we're going to use for Twitter. So for those of you who don't have a live stream account and you'd like to send messages to us via Twitter, you can use hashtag RisingStarsCPD and we'll be able to pick those messages up throughout the course of the session this evening. If you do have a live stream account and you have logged in, there is a message box at the side that will also be able to access the detail on there. And I think that's it for me. Thank you to the people that we've got in the room. We have got a team, again, we've got Alison and Alan joining us, supporting us with the course. I'm going to scoot off round the side in a moment and leave you with the lovely Jane, who's going to lead the session and tell us about, is it jack potatoes and how they...
I'm not.
You're not?
I had some real questions. I was so bowled over because my favourite programme was Autumn Watch. Chris Packham gets questions and I've got questions. So Chris Packham, eat your heart out.
Right,
so
we'll maybe do that with jack potato later.
I'll save that for next week,
okay.
Maybe. So
thank you.
Okay, thank you. Right, so hopefully the clicker will work. Maybe it won't. Because I've got the questions written on my PowerPoint, so I'll start reading them anyway. So the first question I got was from Hanwell School, and they wanted to know if there's any tips on teaching evolution to Year 6. Oh, good. The clicker worked. And then Deborah Porter sent me a lovely question as well, and she'd like some advice on how teachers can evaluate and assess how well children work scientifically. Because at her school, some teachers are anxious about being able to observe all the children and identify who is managing what to do in practical tasks when children are working in groups. They have as many as 30 children in the class, so investigations can become a little chaotic. I think a lot of us will appreciate that, Deborah, especially when they're being asked to think of the variables they would like to test. Also a question from Sharon Smith, so thank you, Sharon. And she would like some examples of children's work or recording. Some teachers feel that recording and evidence can get in the way of real teaching. Again, Sharon, that's an excellent question, and a lot of us will really identify with that, especially during investigations, and how much evidence is enough. And then the last question is from Billinghurst Primary, who brought up I'm really glad you brought this up, Billinghurst Primary, Maintaining Curiosity, the Ofsted document. And they point out that children should be working independently and want to know ways to promote that. And which skills would you start with planning, predicting, selecting apparatus, observing, drawing conclusions? So I'm going to mainly address the first 3 questions to start with, and then I hope we can pull it all together at the end, looking at that Year 6 evolution question. So moving swiftly on. So first of all, I have got a little bit of evidence, but not an awful lot. And do you know what? I wish when I was in the classroom I'd saved more work for my colleagues. I just recommend keep a few bits of evidence of work. In the future, you will be pleased you had. But just have a think, first of all, what time of day do you teach science? This is a little piece of recording. It wasn't actually done in a science lesson. It was done in the literacy lesson that came straight after the science lesson. But the science lesson was done. First thing, we registered and we went on to science, and it was making Play-Doh. And just an aside, how many things do teachers do that would actually be really good for children to do? How many teachers are going home in their own time making Play-Doh? It's a great science lesson. That's just an aside. But because they really love making Play-Doh, they then went on to do lovely writing. This is a Year 1 girl. Some of you may have year ones that are writing better than that, but for this little girl, it was really, really high quality writing. And the way she was talking while she was talking about her writing showed me that she's got quite a good understanding of the science that had gone on in the science lesson. And another thing, how many subjects and skills do you try and teach in a science lesson? Now, this piece of work is from a year 2 boy from my colleague's classroom. She was a really, really experienced teacher and got very, very high quality work from the children. But she was very focused about what she was wanting to do at any one time. And I think so often, especially in science lessons, we try and spread ourselves much too thinly. We're thinking about the quality of the science. We want them to be learning science, but then we're thinking, well, they've got to record it, or they've got to do accurate measurements. It can't be done, can it? If you're really, really pushing them in your literacy lessons, how can you then get that same quality when you're doing a science lesson? It's going to dip a bit, isn't it? This piece of work wasn't done in a science lesson, but it was done following a series of science lessons. As I say, year 2, they'd been out in the playground, lying on their backs, just looking at the clouds, talking about clouds. They'd been boiling kettles, they'd been dancing, they'd watched a YouTube clip, and then they wrote the story of a drop of water. It wasn't actually on our science curriculum. I don't quite know why my colleague had gone off in that direction. She was following the children's interests. She'd give them loads of first-hand, really exciting science experiences, really got them thinking. And then in a literacy lesson, addressing literacy objectives, she got this brilliant writing out of them, which when I looked at it as the science leader, I was delighted with, because it showed me the quality of the children's science learning. And interestingly, when I had a science leader come to spend some time in school with me to find out how we did science at our school, she actually asked if her literacy coordinator could come, because there was a lot of work at this level. But it wasn't about doing literacy in science lessons, it was about using science to inspire literacy, really. So, moving on. Photographs. Obviously, in early years, photographs are used a lot. Sometimes, perhaps a little bit too much, but those well-timed, well-taken photographs really can tell 1,000 words, can't they? Especially if you've got that knowledge behind them. That top picture, for instance, that's a little girl. We've been doing some work with melting ice, or I think we were trying to stop the ice melting, actually. And off her own bat, she decided she wanted to keep a record of how quickly her ice was melting, so she drew around her ice. That told me so much about her understanding of how to conduct an experiment. And below there's an experiment of, again, some year 1 children recording how tall their sunflowers are growing. They're growing them at home, coming back in and keeping a graph in real time. And what made that valuable was also keeping a record of what the children said as they did that. Just thinking about, so often we're thinking about that assessment in the moment, after a topic, after a lesson, but what about at the end of a year? What deep learning's gone on? And this is actually just an example of the reports I used to write with. This was a reception child, and I used a dictaphone. I used a dictaphone a lot because you can't write and concentrate on what a child's saying. And I was able to see what children had learned, and just right near the bottom, understanding the world, where the little boy said, "I love playing in the snow." But I was surprised because I thought that lump of ice wrapped in a coat would melt first. And so he'd actually remembered that moment of learning. This was obviously in the summer when I was writing the reports. That's amazing, isn't it? And really good record of how his learning had come on. Now, just talking about spreading ourselves too thinly. How much can one human being do well at any one time? A lot of you will probably have seen the gorilla playing baseball clip. If you haven't, there's the little YouTube URL code there, so you can watch it later. And it just goes to show you can't, even what's under your nose, you miss. And if you're trying to spread yourself too thinly, can you really manage the whole class, which comes on to, I think it was Deborah Porter's question right near the beginning, wasn't it? How can you manage a whole class? So if we're thinking about that quality time for a few children, because if you spread yourself thinly, it really isn't going to be as good, is it? So it's that quality time for a few children. What do the rest of the class do? And this do, because I think if you've got a small group in front of you, I don't need to tell you what to do. Your teachers, you probably do know what to do. But it's managing everybody else, isn't it? So somebody brought up maintaining curiosity. This is the triennial Ofsted report, and it is well worth reading. If you're not familiar with it, look it up, read it. It really has got lots of very, very sound advice. And on page 12, there's two little clips that I think this is what Billinghurst Primary was referring to. In general, the more responsibility that children were given, the better they learnt. The more they enjoyed their discoveries, and the better they behaved. And then lower down on the same page, it points out that most good and outstanding lessons were in early years foundation stage. 89% of lessons in the early years foundation stage were good or outstanding. It was quite significantly lower in the rest of the primary education. And that gave me pause for thought. What is it about early years that enables teachers to teach better? What is it that makes it easier to teach like that in early years? What barriers are there in Key Stage 1 and Key Stage 2? So first of all, let's just take some lessons from the early years. And then before you think, oh, that Jane, she's an early years teacher, what does she know? There's actually Nicola Beverley's a science consultant in Lincolnshire, and she's studied something that she calls guided science, which is very, very similar. So I'm going to talk about it from an early years perspective because that's what I feel confident doing, but she's done it with Key Stage 2 teachers, and it really, really does work. So first of all, not all children in your class need to be doing the same thing. That really is fine. And it's okay to let children choose from a selection of possible activities. That word choose, in early years we do let children choose. And you'll notice actually they're not choosing from anything they can do in the whole wide world, they're choosing from what's in the classroom. And in a science session, you could be giving children some different choices. And I'll come on for some examples of those choices in a moment. And ideally, differentiation shouldn't be a judgment that you impose on the children, but it should be a challenge that children can rise to according to their needs. Just think about that. That is, differentiation should be an open invitation to children to really achieve. It shouldn't be you labelling and judging children. And that will encourage children to be independent and confident. And even if children haven't done all the activities that are in your classroom, over a period of weeks they might do quite a few of them, but they will learn from each other. In that plenary, when they describe what they've been doing, they will learn from each other. Just thinking about, let me see, which school was it? I think it was Sharon Smith was talking about which activities should be delivered first. You know, what should you introduce first? And I just think that the first thing is just children will need more support when they're using higher order thinking skills. So just move on a little bit more. So strategy 1. Something that happens in early years classrooms, and that's that adult guided leads to independent work. So children can do things independently when you've modelled it, you've supported them, they've done it lots of times with you. But even when you think they've got it, you let them go and they can't do it. Don't be surprised. Things like using a non-fiction book to find out information, a great thing to do in a science lesson, but probably when you've done it quite a few times in your literacy or English lessons first. Writing, again, non-chronological reports, persuasive writing, recounts. Do it in your literacy lesson, build up those skills, then let them, a small group of them that are really interested and want to, do it in their science lessons. Poetry and creative writing fits in well, you know, poetry based on melting ice can work really well. Choosing and using equipment, you've probably done that lots of times and supported them, and gradually you let them do that more and more on their own. Measuring accurately, giving them chances, you'll teach them, you'll really support them to do that in a maths lesson, and then you let them try it out independently in a science lesson. And something like using a computer program to take photographs and insert audio clips. We've got that recording that we were talking about earlier, but it's you've guided them, they've got those skills, and they can go on to do that independently. And strategy 2, one objective. So children are really, really familiar with the objective. So that activity we looked at last week, and somebody from Sharon told us that somebody from her school actually used that. I Thank you, Sharon. That made us all smile. But you can do that what's in the box for any topic, and once children are familiar with it, they could work in a group where they take turns to put objects in a box and get each other to ask those questions. Observational drawing, I'll talk a bit more about that later, but it's something that children that really enjoy drawing can get a lot of science out of that. Designing a board game to teach the topic perhaps to another class or to play with themselves later. And if I could just go back to a view of me, that'd be brilliant. Is that me on there? Great. So this is just one example I've got. You know the game Guess Who? Which is really cool these days. When I was little, it wasn't quite like this, but now it has actually got like a little thing that you can put in with, then you open up these and you ask questions about, if you were doing classifying, you know, is it a mammal, is it a fish, and, you know, does it swim, has it got wings, and you gradually eliminate, and it's a great way of getting children to sort. But the nice thing is, you can take this out, just draw around those little squares, and give children something they can draw their own, and any topic you're doing, you could do it on materials, on space, and I think that's something children would enjoy doing when you're not there working with them directly. And then again, another group can be playing with that when you're not, you know, that could probably last you all year, and it's the sort of thing that children will go back to at wet play times or ask to do in choosing time, or can I make another card to go in that. Just a little tip, it is worth drawing around these, enlarging it onto A3, letting the children draw when they're slightly bigger, and then shrinking it back down to A4 to put on a bit of card and slip into there. So that's just one little suggestion. I think you get a lot of science learning and a lot of enjoyment as well. So we can go back to the slides now, please. Anna, thanks very much. Sorry there's so many slides this week, folks, that I've nearly got to the end of them. Making a story sack. So, can I go back to the... Sorry, Alan. I've not thought this through very well, have I? So this is a story sack that I've made for working with reception, telling the story of the Very Hungry Caterpillar. Am I not up yet?
Yes, you're on there.
I am on, am I? Oh, wow, hi. So this is something I used in school. A lot of children, younger children, loved it. But then ask your older children, could you make something similar, perhaps for a different story? And again, I'll come on to an example of something you can do. But in not just thinking about the story, but thinking about the science learning. So older children making some props to help the children with the Very Hungry Caterpillar, they really reinforce their understanding of life cycles and what have you. So I'll come on to that a little bit more in a minute. If I can go back, I'm keeping you busy now, after a long gap of... I thought it looked like you were snoozing there, so I'll get you busy again. Secondary research, so finding out about a scientist from the past, perhaps designing a game of top trumps based on your research, or writing a letter to the scientist, or, you know, writing a report about the scientist. And strategy 3, just think about your whole school ethos. Have you got a policy about children working outside and in the grounds independently? Because children can go outside, but you need the support of your school to know when it can be done. Are there clear guidelines for children and adults to follow? And are you supported in your school to know how to manage children, what you're allowed to do, how that is going to be managed? And is the independence learnt in one class built upon in the next class? It's so often in early years, as teachers in early years, we're given permission to let our children build that independence, and we don't feel quite so confident to do that as the children go further up the school. So ideally, we should be moving beyond that. So I think I might need to go back to... Oh yeah, we'll just read this and then we'll go on to me. So I'm going to look at two different scenarios. So first of all, Year 3 programme of study, identifying and describing the functions of different parts of flowering plants, root, stem, trunk, leaves and flowers, and explore the part that flowers play in the life cycle of flowering plants, including pollination, seed formation and seed dispersal. And if we can go to me, I shall go through some of the little thoughts I've had about this. So first of all, how about just sending your children outside almost whatever time of year. Just today, I was outside for about 3 minutes and I found actually quite a lot of flowers. It's really nice to see how many different sorts of flowers there are and to get children to notice they're around and start to think, well, I wonder what what's pollinating that just at the moment? It's quite cold and windy out there, but hey. But instead of bringing in the props for children, how about sending them out, get their own flowers, the ones that want to, and then you've probably done something like this where you've dissected a flower and labelled the parts. You probably won't be able to see all this, which is good because I might have got some of my labels wrong. But, you know, I found some stamen and there was the little ovum, quite a lot of petals. It was actually a rose, and there's the sepals and a little stem. But if you sent the children out to pick their own flowers from the school grounds, instead of everybody having the same flower, somebody else could do a dandelion. And it actually gets quite challenging. Where is the ovum in a dandelion? A bit harder to find than in my rose with that nice big plump ovum at the bottom. So something like that, a group could go out, collect the flowers, come in, do this, and then talk about it to the rest of the group. You can be doing something else with another group while the group does that. And you could have done it before. You can repeat activities. Children do consolidate and extend themselves if they've had the chance to repeat them things. Now, I keep banging on about observational drawing. I have got a bit of a bee in my bonnet about observational drawing, and I think I mentioned last week I was talking to a secondary teacher, and he thinks the same. There should be more really looking. And just before this started, before this got quite so limp, I just did a very quick drawing of this, and while I was drawing, all these questions came into my mind. Is that flower there just opening or just closing? I'm not sure. Why are the buds different shape to the spent flowers? It's actually really hairy. You wouldn't notice. What are the hairs for? I noticed that the flowers are in clusters. The buds are all different sizes, and I realised that this flower is obviously adapted to have a succession of flowers, so that even on a windy day like this, when nothing's flowering and nothing's flying to pollinate it, hopefully the next flower will open on a milder day when things can fly. I noticed that the stem is really angular. I noticed that the central veins were pink. This was just within a couple of minutes. I just noticed so much. So do value getting the children to do observational drawing and spend some time doing it with them sometimes. Don't always let them do it on their own. They'll get more out of it if sometimes you help them. Have you ever done this activity where you give children lots of little things, like I've got pipe cleaners and beads? We're primary teachers, so we get excited by things like this. Feathers, paper, Play-Doh, and set the children the challenge of making their own plant. You know, they've got to think about, well, what properties do I need for a stem? And it might seem pretty obvious that you're going to pick a pipe cleaner, but actually talking through why you've chosen a pipe cleaner to be your stem, it's really helping the children think about the properties of a stem. You could have some bits of wool or string to be the roots, you know, and think about why it's got to be that shape. How are you going to have the flower? You're going to choose lovely bright colours for the flowers. Don't just do it once though. It's okay to repeat things. Repeat, reinforce, consolidate, catch up, extend. This is quality learning where those children that didn't quite get it first time have a second bite of the cherry, and those children that did get it can really extend themselves. How about, if you've done this earlier in the year, on a day like today when there's loads of autumn leaves, going out, pick some... send children out, do you remember when we made those flowers? Go out now, choose some materials, what can you use? And I found some lovely petal-shaped flowers. I found a dead seed head to be my stamens. I found a stick to use as my stem. And look, I've even got roots. There's some like dead, dried leaves. I couldn't find anything that was green that actually wasn't a leaf. So I cheated and used paper leaves, but I was rather chuffed with that. I think children get a lot of learning out of that as well. And then what about what you would do with the children? You want to be working, really getting those higher order skills. And this is sometimes a nice thing, just talking to children, giving them a selection of flowers, what would you like to find out? Really helping them to think about what questions they would like to ask, and giving them lots of different question stems to support them in their thinking. What will happen if? That's a lovely question, isn't it? Where? What can? Why? What is? How can? What if? Lots and lots of questions, and insist children, you've got to think of at least one question for each of those, and then help children with your support plan. How can we answer those questions? What sort of inquiry are we going to use? So, moving swiftly on, because poor old whoever it was at the beginning from Hanwell School, I have not forgotten your Year 6 stuff, so I've got a few ideas for Year 6 as well. So, do you know that thing you do, usually I think perhaps Year 2 more, but I think it'll do any age in primary, where you're thinking about, you give them some little bits of wool, and you go out on the grass field and you spread them around, and you see which one's best camouflaged. The children go out and they pick up as many as they can in a certain length of time. You probably make a chart, you know, so in fact, on the grass, is this my grass picture? Yeah, on the grass, the bird wasn't a very good adaptation to be blue, was it? So we actually got quite a lot of blue. But how about doing it not just on grass, but on the playground, on a bit of soil, and then you could actually compare. Is it the same for all of them? Does some colours show up better on others? Are some woolly worms better adapted to different habitats? Now, to extend it a little bit more, I was thinking you could, say you to start off with, put 10 out in each of the habitats, get them in, do a little bit of sum, how many are left? You can work out how many are left. And then you could say, well, each one that's left's going to have 10 babies, because that's the thing about adaptation, isn't it? It's not about surviving, it's about actually passing your genes on. So each one that's left to have 10 babies, so you might end up there now where you had 10 blue ones before. If 3 were left, you're now going to have 30 blue ones. And do that in each of your areas. Again, go out, do your sums, how many's left, and you'll really see how those populations get bigger. And you might be surprised because the one that's actually well adapted becomes very, very common. So actually you start to find more of that one. A bit like sparrows. They're really well adapted because they're well camouflaged. So we have loads of sparrows, and then you see them more than bullfinches. I hope that makes sense. I'm running out of time now, so let's crack on with some more of my... Oh yes, books. So how about, do you know I was talking about the book bags? Here's a nice little book about evolution. It's about the rinky-dinks that get separated over a few millennia and evolve in different ways because they're in different habitats. How about getting your Year 6s to make a book bag for this story that they could then share with younger children? Or here's another story about the evolution of dinosaurs to get flight. How about them reading through this and thinking, how is this a good model for evolution, and what misconceptions could it maybe they could write to Benedict Blaithwaite and say why they think this could be even better. What else did I have for this? Because there was something else. Oh, board games. Now, I was thinking you could have some sort of board game, but I'd want your Year 6s to invent it. I've tried to do it. I'd got coloured squares on my living room, and I'd got coloured things, and you shake a dice, and that percentage go. If your green counters are on the green things, they go. But explain what you want the Year 6s to do, and get them to design their own board game. So I'm suddenly starting to get one thing left, I think. And then for your teacher activity, how about just thinking about, I've heard a lot of people say, oh, I think one day our thumbs are going to get longer, because that's a common misconception, isn't it? Because people think that acquired characteristics are inheritable. So how about having a discussion with your children about whether longer thumbs will become more common because of the rise in technology. So, Chris Packer, meet your heart out. I think I've got to the end. Is there anything else I need to say or do, or just ask for questions?
No. I'm not sure, Jen. Sorry, I'm just
no, that's okay.
posting a link to a little video clip on the STEM Centre site around the caterpillar hunt for people who would like to know more about it. Deborah Herridge did a little video clip.
Oh, I see,
so
right.
I'm just trying to post that on the side.
Lovely.
I think we're pretty quiet on Twitter and...
Have they all run away?
It would appear so. I'm just going to stall a little bit to see if anything comes through.
Okey-doke.
But it is looking a little bit sparse, so I'll just give it a few more seconds. A bit more
remember,
space.
if you have watched this or you watch it in the next few days, if you have got any questions, do send them in, because, well, why should Chris Packer get all the questions? That's what I want to know. So, I'm not very good at thinking of things to say.
Okay, I think if we have any more questions come through, we can pick them up next week. So
yes,
thank you very much for your time. Thank you to everybody that's joined us, and we will be using live stream next week. So if people do want to register and find it easier to use the message board at the side, then we can respond to questions. We did have a few issues around technical questions there, but I think that's it for this evening. So thank you very much.